after copper sulfate is zinc, Zn2 plus ions. Let's see a Zn2 plus ion, zinc sulfate. Okay, so let me take, this is white, zinc, magnesium, aluminium, sodium, potassium, ammonium, these are all white in color, all salts are white in color. So we take a small amount of zinc sulfate and then add water to it. Made a solution. Now zinc sulfate Zn2 plus ions, when it reacts with NaOH, what type of precipitate it will give, you observe. This will be white in color, so you have to look close. You could see the difference. Immediately one gelatinous precipitate was formed. Gelatinous, the whole thing has turned gelatinous, see. It's not dropping off. If I try to drop this also, this is such a heavy precipitate, it's not falling. So it is just a gelatinous precipitate like this that is formed. What is the gelatinous precipitate of? It is of zinc hydroxide, ZnOH2, white gelatinous precipitate of zinc hydroxide. If to the salt solution, when NaOH is added and a white gelatinous precipitate is formed, then it is zinc ions present in it, Zn2 plus ions present in it. Now let us see what happens. We add excess of, we'll try to dissolve these whatever is on the sides of the test tube in excess of soluble. So in excess of NaOH, it becomes soluble. The precipitate is no longer there. So it is soluble in excess. White gelatinous precipitate which is soluble in excess of Na2SO4. Now ZnOH2, I have not written that equation over here. Actually this ZnOH2 plus 2 NaOH, it forms what salt? ZnOH2, this white gelatinous precipitate, plus 2 NaOH, this forms Na2ZnO2, which is a soluble salt, Na2 sodium zincate, Na2ZnO2. This is a Na2ZnO2 is a, and water, H2O of course. So this Na2ZnO2 is a soluble salt. That is why we saw that the precipitate dissolved in excess of NaOH. Now we come to lead nitrate. Here lead nitrate. This is lead nitrate, white salt as I said. So lead nitrate, first we will make a solution, take one test tube and form a solution. I am keeping this here. In this I will add water. And make a solution of lead nitrate. This is lead nitrate. If you want a clear solution, just decant it out from top. Here is a clear solution. And to the lead nitrate, let us see what happens when we add the the reagent. When we add reagent NaOH caustic alkali, you get a chalky white precipitate. This is how you see the two whites, both are whites. Zinc sulfate also gives a white precipitate. This was a gelatinous white precipitate and this gives a chalky white precipitate, a heavy white precipitate. Okay, it's very, very clear, distinct. So chalky white precipitate of lead hydroxide when you are treating lead nitrate or any soluble salt of lead with, lead nitrate is the only soluble salt of lead. So you are taking lead nitrate solution and you are adding NaOH, strong alkali, and what do we get? We get a chalky white. How this is not a distinction, but okay, I'll tell you later when we do ammonium hydroxide. If you are asked to distinguish between Zn2 plus ions and Pb2 plus ions, you can't distinguish on the basis of white because both are white PPT. If the color is too distinct, like say this is green and this is brown, then you can distinguish on the basis of color. But where both are white in color, this is just a gelatinous white PPT and this is a chalky white precipitate, but both are white in color, then you cannot give the test as a distinguishing test. In that case, what we will do, we will use ammonium hydroxide, because in ammonium hydroxide, zinc is soluble in excess, lead is not. Lead is insoluble. Lead hydroxide is insoluble in excess of ammonium hydroxide. But in excess of NaOH, lead is also soluble. So this can't be used as a distinguishing test. Means zinc hydroxide, which is a gelatinous white precipitate, this is also soluble in excess of reagent, and lead hydroxide, which is a chalky white precipitate, that is also soluble in excess of reagent. So it is not accepted as a distinguishing test. So let's see what happens if when this precipitate is, excess of reagent is added to the precipitate. See, it becomes soluble, it dissolves. So both zinc and lead are soluble in excess of reagent. What will this form? This will form sodium plumbate, Na2ZnO2, sodium zincate in case of zinc, and this will be Na2, PbO2 will be sodium zincate is formed, sodium plumbate is formed over here. And both are soluble salts and they remain in solution. You can't isolate you can't take it out as a crystalline salt. These remain in solution only. These salts are found in solution only. Now the last one is the non-metallic cation, NH4 plus. NH4 plus is the cation over here, and this is not a metal, okay. So NH4, ammonium salts, NH4 plus ion, if this is also a cation, but are not a metal cation. Now how do you identify a non-metal cation like ammonium ion? Ammonium ion is detected by when any ammonium salt is heated with a caustic alkali, with NaOH, CaOH2 is heated with a caustic alkali. See the sign, this means it is heated. Then it gives sodium chloride, ammonia and water. Means this ammonia, pungent smelling gas comes out, which turns Nessler's reagent brown or gives dense white fumes with rod dipped in conc HCl. So let's do that test and see. We will take an ammonium salt. All ammonium salts are again white in color. Okay, all ammonium salts are white in color. So in a test tube, we will take an ammonium salt. Here, this one. This is ammonium chloride. I have taken ammonium chloride. So ammonium chloride. To this only I can add, of course. Add a caustic alkali, NaOH. Now I am going to heat it and keep the test materials ready. Test materials means the gas that will be coming out is ammonia. So ammonia has to be, how do you test ammonia? Ammonia is a rod dipped in HCl, conc HCl. This is conc HCl. If I take a rod and dip it in conc HCl like this and then bring it near the mouth of the test tube, it will give a, or if I take a paper, where is the paper? Okay, Nessler's reagent is, you need a paper for that, it's not over here. Let's see this test now. What was taken in this? Ammonium chloride, any ammonium salt and caustic alkali, and then it is heated. A pungent smelling, ammonia has a very pungent smell. So pungent smelling gas will be coming out from here. You can't smell it, of course. Behind that camera you can't smell this, I can smell it, but here what you can do is you can take a test, that is you dip a rod in HCl. If the gas is evolving, then it will give a dense white fumes. Can you observe the faint dense white fumes? In close up maybe, if you see this. Fumes. From here I can see, but if you can, whether you can see it or not, I don't know. So it gives a dense white fumes with this. Give me a paper. And Nessler's reagent I'll try to show you in this. Nessler's reagent brown. Okay, so this is Nessler's reagent, and I wet this paper with, actually filter paper should be there. Now this Nessler's reagent paper turns brown in color. Seems the gas has all evolved already. Let's see with this. Can you see the fumes now? Dense white fumes coming out. So that was ammonia gas. And now we will do the tests with ammonium hydroxide, a dilute alkali.